Hello grade 12s, this is just a video on the tangent work in analytical geometry. So just remember, a tangent is a line that only touches a circle at one specific point. You need to also remember that using your geometry, that a tangent is perpendicular to a radius, and using your grade 11 analytical, that if you multiply perpendicular lines, then the gradients of their perpendicular lines, then it will get the answer of -1. All right, so that's going to be important when working with this section. Then example 9 here shows what's expected of you. It says determine the equation of a tangent. Now, very specifically, a tangent is a straight line. So a tangent is a straight line, and its equation is y equals mx plus c, or if you use y minus y1 equals m into x minus x1, that's fine. Both are completely fine. I use y equals mx plus c, but it really makes no difference. It gets you the same answer. Determine the equation of the tangent, so a straight line, to the circle. Here they've given you the circle. So now you already know that its radius is going to be the root of 10. Your center is going to be 2 and -5 from those points. And they give you a separate point of 5 and -6. Okay, the diagram shows you all of this, but you wouldn't necessarily get a diagram in an exam. So the circle center is 2 and -5. The gradient of the radius. So you've got to work out the gradient of the radius using the 2 points. Okay. So the tangent is happening. And there's a nice fancy statement for this. This is the point of tangency. The point of tangency. In other words, where the tangent touches the circle, where the straight line touches a circle. So how do we work out gradient? We take y2 minus y1 over x2 minus x1. I don't have space here, so I'm just going to do it next to it. Please do under. And so I'm going to work with y2, let's say, is -6. Minus y1 is going to be the -5. And then it's going to be 5 minus 2. So we end up with, -1 over 3. So -1 over 3 is the gradient of the radius, which means the gradient of the tangent must be +3. If you need a little working out on the side, it's because you -1/3 times something will get you -1. So it always has to be the additive inverse. So if that's negative, this has to be positive, because when you multiply negative and positive, you still get a negative. And then what would cancel out the 3? It would be 3/1 to get you your -1. So it's always the additive inverse. You flip and change the sign. And don't forget to give your reason. Tan is perpendicular to a radius. All right, so that was your radius that we used. And now we have the gradient of our tangent. So now find the equation. Again, I'm going to use y equals mx plus c, but you are more than welcome to use the longer formula that is in your textbook on page 207. Right, so y is equal to mx plus c. Now remember, this is the tangent, so y is equal to 3x plus c. Now, once you have a y, x, and another letter, so x, y, and another letter, you subs a point. The only point that touches the actual tangent is 5 and -6. So I'm going to subs in 5 and -6 in place of x and y. So c is going to equal -21. And so therefore your equation of your tangent is 3x minus 21. For example 10, also on page 207 to 208 of your textbook, they say there that the sketch alongside, you have your P, -3 and 2 is the center of the circle. E is an x-intercept of the circle, so we know y is equal to 0. A, B, C, D, and E, F are tangents to the circle. So definitely here, this is going through the center. It's definitely a diameter or a radius, so there's 90 degrees there. Same over here. The equation of AB is given to you as y equals 2x plus 13. So the gradient of that line, remember y equals mx plus c, is 2. All right, so then you know the gradient of this will be perpendicular to the gradient of the radius or the diameter. Okay, so it says now, determine the equation of AC. So AC is our diameter or our radius doubled. So we just work it out as a straight line. We know then, so we have the gradient, the gradient of AB is equal to 2. That's from the equation. They've given it to you. So given. Right, so then the gradient of AC is going to be negative a half because a tangent is perpendicular to a radius. And so they have that inverse relationship of gradients. So then the diameter is a straight line. So again, we're using y equals mx plus c. And then what point goes or lies along the red line is P. So I'm going to subs in. P is negative 3 and 2. So when we work out C, it's equal to a half. So y equals negative a half x plus a half. That's for the equation of AC. That's the red line. Okay, then the coordinates of A. Now, coordinates of A is the point of intersection of our two lines. So it's the point of intersection of AB and AC where those meet. So when we have intersection or meeting, we make the equations equal to each other. So we first need the equation of our AB, which they gave us, and then our AC, which we found out. And then we put them together. We make them equal to each other because they're both equal to y, so we can just join them together. All right, so then just solving for that, we get x is equal to negative 5, and then to get your y value, you subs it into one of the equations. So you can subs it into the easier one, which is the given one. And we get the answer of 3. So the coordinates of A are negative 5 and 3. That is the point of tangency. Okay, so for question C now, they want the equation of CD. Now CD is going to have the same gradient as AB because they're both 90 degrees here, so we have a set of parallel lines. Okay, imagine that idea of an alternate angle situation, for example, but also the fact that they're both perpendicular to the same line, so they must be parallel to each other. Or you can just think the fact that they are perpendicular to AC, so then AC's gradient is negative a half, DC's gradient must be positive 2. All right, so we have a point, we have the gradient, but in order to find an equation of a straight line, we need a point as well. So we need point C or D, but C is the more likely because it actually is attached to the circle, which we have more information for. Now, we already know that A is negative 5 and 3. P is the center of the circle, and then C is where we're looking for. So now when we're looking at a diameter, which AC is the diameter, P is the midpoint of it. So if you've got a line, AC, and you've got the midpoint, you can then use the midpoint formula in reverse to work it out. Okay, so that's what we're going to do. So when you're given the midpoint, you split it into two separate questions. So you have your x is equal to, so that's x of your midpoint is equal to x of the point A plus x of the point C divided by 2. And the same for the y values. So we're going to substitute in the x of the P value, and then we know the x of the A value. We're looking for the x of the C value. And then we have the y of the P. We have the y of the A, and so then we're going to just work out the y of the C. All right, so we just cross multiply. That gets us -6 equals -5 plus x. Take it across. X becomes -1. Cross multiply, that's 4. 3 plus y, so that becomes 1. So your point C is -1 and 1. And then you can use your y equals mx plus c to work out the equation of CD, which we have over there. All right, so you subs in your gradient, then you subs in the point that you have on that line, which in this case is C, and then you work out the equation of that straight line. Then for D, they're asking you for the equation of the circle. Okay, so for the equation of a circle where the center is not the origin, we have to say x, okay, minus your a value all squared plus y minus your b value all squared equals your r squared. So your a and your b is your center point. Your radius is squared in this case. So now there's two options of how you could do this. You could work out the radius length by using just the distance formula between P to A or P to C, or you can work out the length of AC and halve it, or you can do the center of the circle and then subs in A or C into the equation to get R by itself. All right, so I'm going to go with the method of subsing in. Okay, so when I subs in the center of the circle, remember it's -3 and +2. So when you put a negative with a negative, it becomes positive. A negative with a positive, it stays negative. And then I'm subsing in point A. It doesn't matter if you use A or C. It's going to get you the same answer. So R squared equals 5. So your equation, you bring it from this step. X plus 3 all squared plus y minus 2 all squared equals 5. Remember, we want r squared. We don't want r by itself. Now for E, the equation of EF, firstly, we don't have a gradient and we don't have a point, but we do know, as we said, that E is an x-intercept, so y is equal to 0. It's an x-intercept specifically of our circle. Okay, so it's not only where the tangent cuts, but also the circle. Because whatever happens at point E happens for the circle and the tangent at the same time. So in our equation for our circle, which is x plus 3 all squared plus y minus 2 all squared equals 5, I can make y equal to 0 at point E. And then all we'll have left in the question is our x value. And then we can solve for x, and then we'll have a point of whatever the x value is in 0, and then we can work out our gradient and use our y equals mx plus c. All right, so if we sort out all the numbers and get them to one side, the constants, then all I have to do is square root both sides is plus minus 1, so which means we're going to get x is equal to -2, or x is going to equal -4. Now we've got to choose which one is valid, so we've got to see, well, point E sits between, here's -3 and here's -5. So it must be x is equal to -4 then, because -2 would sit somewhere after that p value. All right, so and specifically, what did we get point C to be? Point C was -1 and 1. So then it would have to lie here to be -2. So our point E is -4 and 0. So now we've got a point. Now we just got to work out the gradient. And now if we go back, I'm just going to get rid of a couple of this. Right, so we could actually draw in, so we know E is -4 and 0. We know this is a radius, so it's 90 degrees. So you could construct PE, work out its radius, but then also you could just think that these would be perpendicular here as well. So AC must be parallel to EF. So EF must have the same gradient as AC. So your gradient of PE, what was the gradient of AC? AC's gradient was negative a half. So then the gradient of EF is also going to be negative a half. Now you'd have to show that the gradient of PE is going to be 0 minus 2 over negative 4 plus 3. That's going to be 2. So the gradient of EF is going to be negative a half because of tangent perp to radius. Or unless you give some explanation of parallel lines. So then my y equals mx plus c. I'm going to substitute in my point E now. So point E fits in, and then we solve for our c value. Our c value ends up being negative 2. All right, so therefore y equals negative a half x minus 2 is your equation for EF. So when it comes to these tangents situations, it's all straight line and basic grade 11 and grade 10 analytical with parallel, perpendicular, y equals mx plus c. Very little of the metric stuff, just really your knowledge of your circle formula from before. Point E in now. You can now work on exercise 3, and the memo for this exercise, well, you can get the answers from the back of your textbook now, and if you need help with it, please just ask one of your teachers, and we can help you with it. Then just the last thing, well, is the last part of exercise 3, and then this is just something that they often ask you about, is the relationship between a circle and a point. So they'll ask you about a point. Does it lie on the circle, in the circle, or outside the circle? So what you need to know is what the length of your radius is, which you'll be able to get from your equation. Let's say you have x plus 3 all squared plus y minus 5 all squared equals 25. Okay, so we know our radius is going to be 5 because that is r squared. And then, so let's say your center of your circle in this case is negative 3 and 5, and they'll give you a point. And then if that point, once you work out the distance from your center to the point, so you use your distance formula, you compare that to the length of the radius. If it is shorter than the radius, it means the point is inside the circle. If it's equal to the radius, then it's on the circle. And if it's longer than the radius, it means the point is outside the circle. So you've gone the full radius length, and then you've gone even further. Right, they often like to ask those questions. Okay, then we can look at the relationship between different circles. It's on page 212 of your textbook. It's really set out nicely there. So we can determine the relationship between any two circles by comparing the distance between their centers to the sum or difference of their radii. So the capital R is the radius of this larger circle, and then little r is the radius of the smaller circle, and d is the distance between their centers. So let's just start with circles that touch externally. So circles that touch externally, the d is the distance between their centers. You can see that if they just touch on the edge, just outside, it means there would be one radius, there would be the other. It's the full length of that distance line. So it's their two radii added together. If it's equal to the distance between their centers, then they touch externally at that one point. It's like they are tangents to each other, but not in the sense of a straight line, but they just touch. So you would be given the center of this one circle, center of the other circle, use the distance formula to work out their distance, and then figure out your radius from your equation or whatever information they've given you, and then add them together. If those two answers are equal, they touch in that way. If the distance between their centers is bigger than the distance of their radii, which in this case it would be because it's got this extra little piece, it means they're not touching. Then for this type, if you add and subtract the radii and the distance fits between them, so the number that you get for the subtraction, the number you get for the adding, and then the number that you've worked out with your distance formula between their centers, right? If that distance fits between your two answers of adding and subtracting, then your circles intersect at 2 points, all right? If when you subtract and your distance is equal to that subtraction, they are touching but on the inside. It's different to when they were touching after adding, that's on the outside. And then lastly, when your distance is less than the subtraction between the radii, then they don't intersect, but the one is inside the other. All right, again, page 112 to 113 has this, as well as some extra examples on this, just for your interest. These are the more kind of like out-of-the-box thinking questions, but you can study this if you'd like. Then it's also important to just note page 209, the length of a tangent. It's good to work through that. So page 209 in your textbooks, as well as 215 in your textbooks, 215. Also have some additional types that they could ask you about the lengths of tangents and about whether a tangent cuts a circle or not.